All right, everyone, welcome to another episode of the TWiML AI podcast. I am your host, Sam Charrington, and today I am joined by Shreya Rajpal. Shreya is founder and CEO of Guardrails AI. Before we get going, be sure to take a moment to hit that subscribe button wherever you're listening to today's show. Shreya, welcome to the podcast.
Thank you for inviting me, Sam. Excited to be here.
I'm really excited about our conversation as well. We'll be talking about AI safety, among other topics. But before we do that, I'd love to have you share a little bit about your background.
I'm Shreya. I am the founder and CEO of Guardrails AI. The company really started around an open source project that I created called Guardrails. So it focuses on, how do you take this fantastic technology of large language models and make sure that you can reliably use it in production scenarios. But in the past, I spent about a decade or so in machine learning. I've worked kind of across the stack, starting out doing research in not even deep learning and classical AI systems, which seems a little bit archaic now. Then did a bunch of research in deep learning, spent a number of years in the self-driving space, basically training models and doing machine learning in every part of the stack in self-driving. And then joined an MLOps company called Predabase as their founding engineer, where I led their machine learning infrastructure team. So I've gone the full gamut from research, applied ML infrastructure, and now focusing on safety for AI systems in LLMs.
I guess we should jump right in and talk about, when you say LLM safety, what are some of the things that you're thinking about? Is it, just hallucinations, or are there more safety issues that, you and the market are concerned about?
Yeah, I think hallucinations are definitely top of mind for everybody. I think they're also one of the most obvious failure modes of LLMs, where you ask it a question and you're like, no, I know the answer to that, and I know that what you just kind of printed, as confident as you sound, is not the right answer.
Yeah.
So hallucinations are definitely top of mind for a lot of people, and as you build applications and then run them at scale, run them where you have a bunch of users using a prototype, so it's not just a side project that you build and you're trying out. You truly start seeing some of the scale of hallucinations, and how the same query, the same data set, source, etc., will result in different answers. But that's, to some degree, that's barely scratching the surface, because a lot of the promise of LLMs, a lot of the really fascinating, amazing demos that all of us saw, end of last year, this year, etc., why they were fascinating is that you kind of see the potential that they have to disrupt traditional work, disrupt a lot of add a lot of automation or human augmentation, etc. And that's where a lot of the promise lies. And we make a lot of assumptions about the reliable, how reliable humans are when you give them a certain instruction, right? You're like, hey, don't if you're working for McDonald's, never ever mention Burger King. McDonald's is always the top the top burger chain for you. But if you want to bring in an AI model that kind of does that, even following simple instructions like that might not always be respected, right? Especially as these models are poked and prodded and deployed at scale, not just individually, but as part of these larger complex systems. So ensuring that, in addition to hallucinations, ensuring that all of these very domain specific, very industry specific constraints, which we just expect humans to kind of just know and get, are suddenly assumptions that are not valid anymore for LLMs. And I think that is a much more kind of functional interpretation of AI safety, within a domain, within an industry, within an application or use case, etc. So those are the across the gamut of things that we're focusing on. That includes this set of problems as well.
And have you come across a taxonomization of these kinds of concerns, or have do you have a mental model of the different categories of concerns, or do they all fall under hallucination? Or yeah, how do you think about the different failure modes?
Yeah, I think that's a great question, honestly. So hallucination is part of it. In terms of taxonomization, I am a huge fan of taxonomization. It's how I build, mental models about whatever I'm working in. So even within hallucination, there's a taxonomy. Not all hallucinations are kind of created equal. Some are more harmful than others, and there's ways to kind of categorize, classify, evaluate them separately. But outside of hallucinations, like there's a lot of risk that gets exposed to customers or builders when they're working with LLMs, and this might go anywhere from just like straight up performance risk, where even if the model is not hallucinating, it's just straight up not helpful. It's not able to give you the kinds of like detail or the kinds of questions that you're looking for. Like maybe it's too verbose, maybe it's too terse and doesn't have enough context or the relevant context. Maybe even if it's correct, maybe it's focusing on the wrong section of documents or the wrong section of like text, etc., to generate an answer, right? So one of the risks is just like straight up like performance or like accuracy would be a very simple way of thinking about it. But there's a lot of other risks as these systems get deployed into real world organizations and real world scenarios. So brand risk is an obvious one, right? Where the model might not be hallucinating, but it might end up saying something that ends up being a brand risk to whichever organization wants to use these LLMs or AI models in production, right? Another one might be like compliance risk, right, or regulatory risk, where a lot of the where essentially the model, even if it's factually correct, or maybe it may or may not be factually correct, but is doing an action or a behavior that the organization does not have the authorization to do, right? A very very simple example of that is, let's say you're building like a health chatbot whose only purpose is to help you with your billing inquiries. In that case, that chatbot should never ever give medical advice. You'd be surprised by like how easy it is to jailbreak these systems, and
Yeah.
how easy it is to like get it to give medical advice when it's actually working in production. So
Your bill is
things
due in 28 days, but by the way, have you considered this alternative medicine approach?
yeah, exactly, especially when there's like this the most common UX for deploying these systems currently is like a chatbot, right? So it's very conversational, it's
And
very
people want to
there's a
chat with it.
people want to chat with it. They're like, okay, my bill is due. Oh no, what am I going to do now? And you're like, okay, actually, I can't really tell you. I can only help you with billing inquiries. So
Hmm.
making sure that these systems don't behave in a way where they cause like compliance or regulatory risk for their parent organizations. I think there's a bunch of other kind of like risk factors here that kind of open up, but there's it's broadly this classification of like how even if the model is factually correct, or it's hard to evaluate whether it's factually correct in the case of like medical advice, but it just behaves in a manner that opens up a can of worms for whatever whoever the organization in charge is.
And then you said that for even within hallucination, you've got a subcategorization or taxonomization of types of hallucination. Can you share a little bit about that?
So on the highest level, it depends on the workflow that somebody has when they're building with LLMs. So one of the most common patterns that we've seen, be very widely adopted whenever for any application that is being put out into production is retrieval augmented generation, or RAG. Where just on a very high level, retrieval augmented generation is that you have some private data source. Let's say if you're internal to the company, like maybe this is your employee handbook or something, and you want to build a system that somebody can come to the system, ask questions in natural language from the handbook, and the LLM or the application that you're building like looks at the employee handbook and then responds to questions from that. So that's the high level goal of like retrieval augmented generation, which is you retrieve some relevant documents first, you augment the LLM's knowledge with those retrieved documents, and then using all of this additional context, you generate some response. So if you're doing retrieval augmented generation, a lot of the assumption that stakeholders have as they're going into this is making sure that only answer from the set of questions that are present in the documents that I give you. Don't use your world model or the entire internet that you were trained on to just inject a few sentences here or there just from your own information. Just stick to what I've provided you, right? So in this case, like one very very common failure mode is that you build retrieval augmented generation systems, And as the LLM is like generating some text, it will not just look at the documents that you have, but like add, some extra flavor here or there. Maybe that flavor is right, maybe that flavor is wrong, but the intention here is just to make sure that you're just not opening up that that Pandora's box, and you're making sure that only what you know to be the source of truth, which is your documents, are what the LM is using for answering. So that is kind of like closed domain hallucination, right? Another kind of like flip side of this is that you just have a general question answering system. You're not building a RAG system, and you maybe have a QA bot that is just a companion bot or just a conversational agent, etc. In that case, like the model can still hallucinate, but it's like it's not constrained to the domain that you provided it, right? So there's just that like top level classification, depending on are you providing like some source of truth that you want to be respected, or does it are you expecting the model to rely on its world model to answer your questions? I think even within that, then you can specify like what are the types of hallucinations. So is it messing up like some specific entities, right, where the fact is true but it's just talking about a different entity, or it's talking about instead of like in your employee handbook you have like you can only take like 30 leaves and you have to apply for permission from your manager, it's you can only take like 25 leaves and you have to apply for permission from your manager, right? So it's messing up like specific entities or specific values in the text, or it is maybe like completely misrepresenting the meaning, or it's adding like ambiguous information, etc. So there you kind of like can become like way more specific with like what are the what the specific type of like hallucination represents.
You mentioned in the context of closed domain hallucination, RAG, uh, and as you mentioned, RAG has become very popular as a way to, I guess, limit the failure surface of LLMs. Um, I think the existence of closed domain hallucination as one of your subcategories suggests that RAG in and of itself is not sufficient to solve the problem. But I'm wondering if you can elaborate a little bit on the kinds of experiences that you've seen with folks using RAG, and an assessment of the degree to which it solves the problem.
In terms of the degree to which RAG solves the problem, I would say that without RAG, a lot of the LLM adoption we're seeing today would just not exist. You would, at least a lot of the excitement in enterprises and corporations, etc., to like bring LLMs into the fold and see how they can be used. I would suspect that that would be a lot more muted if RAG didn't exist. So I don't think right now that there are sufficient alternatives to RAG outside of fine tuning, and even then you might have like way more of a lift using RAG than you would with fine tuning. Even ignoring the cost of fine tuning, ignoring the effort, and ignoring the requirements that you need to have on having a data set that's curated and that actually works, etc., that is needed for fine tuning. Ignoring all of that, even if you just did RAG versus did fine tuning, you might end up, it's very possible that you're going to end up with like better performance with RAG than you would with fine tuning. So I don't think that I don't think we can do away with RAG at this point. I do think it's a very essential part of the LLM stack. But then even within RAG, right, like I think the most common thing we see is that like I gave it this text, but it's not respected, right? Like it just added extra context or added extra information that wasn't present in the text, that I just don't want it to have. Or it maybe responded with something that I didn't want it to respond to, or maybe someone asked a question that wasn't actually in the documents at all. So the LLM, once it couldn't find like a relevant document or something, just ended up generating information, that again, relying on its world model, to generate some text. So I think it's this kind of constant push and pull between like using how capable and how adaptable these models are, but then putting like some constraints on them, right? Like using that capability, but only making it work on your domain, your data, your text, and trying to make it like fight its own like its own capabilities where it wants to rely on like all of this other kind of like knowledge that it's been trained on. So I think that's pretty much like the most common failure mode, where you kind of like give it some text, but it'll just add extra context, extra information. That ends up being most common. But then you also have like, to a lesser degree, examples where you give it some context, but it also just straight up like negates it, or it like refuses to find what the relevant piece of information is. So maybe you're like, okay, what is the leave policy? The retrieval part of it might work correctly, but you run this at scale, you'll kind of find that like, okay, what is my leave policy? And you end up like generating a response where, even if here's the leave policy is in the text that you give it, it would just end up generating responses of like, oh, sorry, I couldn't find anything about your leave policy. And or maybe like you don't have a leave policy, etc., and just respond with that. So the challenge here ends up becoming that a lot of the excitement in the space, it's because like it triggers the imagination of what's possible with LLMs, right? But the bet that everybody working in the space is making is that this technology is going to be so powerful that it permeates every, like it's going to be everywhere. It's going to be every tech that you use is going to have an assistant, and it's going to be on your phone, and maybe it's a companion, maybe it's a sales assistant, etc. But in order to do that, if you think about like, okay, if I only if I was querying a database with SQL, I only expect it to work like, maybe I'm pulling a number out of the hat here, but like I only expect it to work like maybe 70% of the time, right? That would be like, that is not how software works today. You have like
Yeah.
expectations of reliability. You have some implicit contract with like software when you use it, but that's not the case with machine learning, and that's not the case with these LLMs today. So in order to get to that stage where this technology is adopted, and it's everywhere, like we would need to cross that hurdle and make sure that we don't run into these problems.
Yeah, one of the interesting things that you've emphasized thus far is the aspect of these problems in which they appear at scale. Like you can build a system, you can interact with it, and everything could be fine. But when you scale it across many requests, if the probability of a failure is small, at scale it's going to manifest. How can builders like wrap their head around the failure rate essentially of their systems if they need to scale? Do we have the tooling to, are there load generation tools or the analog for that for LLMs? Like, what's the right set of tooling to wrap your head around the problem?
I think that's a very, very exciting question. I think it's a very active area in this,
Yeah.
in this space right now, which is, how do you actually figure out how well these models work, or how well this workflow or application works, right? So we're in this kind of like interesting space where I'm sure other guests you've had on the podcast before have mentioned this as well, but we're in this interesting point where the ML metrics are actually a little bit behind where the technology is. So if you take, the classic case of like summarization, like the metrics that we'd use for summarization, for the longest time aren't usable anymore, because LLMs will do worse on the metrics but actually would have generated better summaries. And that is also because there's no one right way to do generation. Like you can generate a text in multiple different ways, have like different sentence structures, etc., and all of that would still be a valid generation, right? So how do you kind of capture that? I think in terms of tooling, it's a very, very active space. Like a lot of people in academia, in industry, are really looking into, like what the right way to kind of like solve this problem is. And I think one of the most like well adopted ways to solve this problem and to figure out how well evaluation works is to get the LLM to self evaluate itself, right? So let's say you're using OpenAI to generate some text from some documents that you gave it, then you would do a follow-up query where like, oh, actually, given this text and given this response, is this truthful, is this factual, am I missing anything, etc., right? So this LLM self-evaluation is like one of the most common patterns right now, and I think it's more because of necessity, rather than anything else, because we are at this point in time, I think there aren't as many tools available outside of LLM self-evaluation. But at the same time, it personally for me, it makes me very uncomfortable, where if you're using the LLMs to self-evaluate itself, like the first question is, okay, like who will guard the guards? Like, how
Right.
do you know the evaluation isn't hallucinated, right? The
Right.
second is that LLMs have this very very fascinating tendency where they're, to some degree, they're like next token predictors. And if you just ask it to, let's say for example, you ask it to generate like a score between 1 to 5 or 1 to 10, there's a bunch of research where it would be way more likely to generate like one number, because it's just like more conditioned to generate that number, right? So a much more simpler way of like thinking about this problem is you ask the LLM to generate a random number between 1 to 10, and you would expect that the distribution looks uniform, where like each number kind of comes up roughly similar number of times. But you end up finding like, I forget what the actual number was in these tests, like 3 or something. Like 3
Mhm.
would just be way more overrepresented, like 70% of the, I'm pulling numbers out of my hat here just to kind of like talk about the problem, but let's say it's something like
Yeah.
70% of the times you'd get a 3, and then everything else would be very low.
So rate the factuality of the previously generated response on a scale of 1 to 6, excluding the number three.
Yeah,
It starts to get
exactly.
a little wonky.
Yeah, it's we're kind of in the wild west of like understanding the capabilities, and controlling and constraining the capabilities of these things. So it's pretty fascinating, like where we are tech wise.
Yeah.
I think like other issues are that, okay, if you ask the LLM to once again evaluate itself, compare like one generated text versus another, and you're like, okay, which text is better, right? And you're just looking for a factual evaluation. LLMs are, they're a little bit narcissistic in that they find their own work way like better more often than they find like human generated text. So they're
Right.
much more likely to rate themselves higher than they are like human text, etc. So there's like all of these like really fun challenges where I do, like some of the other benchmarks that we did internally, you use the LM to evaluate yourself. You don't change anything. No hyperparameter is changed, zero temperature. And you run this evaluation multiple times, and you're going to get, varying, like it's within some range, but it's not a small range. Like it's a non-trivial, difference in, like, let's say accuracy, right? Like you'd get a differently varying accuracy depending on when you run it. So I think like I personally am very very uncomfortable with like LLMs being evaluated. So in terms of the tooling, I think like people are looking into how do you kind of like bridge this gap between traditional ML tooling, which was way more reliable, versus something that can accurately evaluate the flexibility of LLMs. And I think as with all ML problems, the first step is really being able to like curate a data set or have a data set that has, maybe you have like human labelers or human experts kind of look at it, that kind of captures these tasks. So it varies from task to task, but that is where we are kind of like, that's the lay of the land a little bit.
And does the data set that you referenced, does that exist, or is it, and even can it exist generally, or does everyone need to kind of curate their own because the failure modes are so context specific?
Yeah, I think it's the latter, unfortunately, where the failure modes are so context specific that every org, every kind of every company, every startup has to kind of like figure out internally what they're kind of building this for. So if you have let's say internal company document question answering, versus if you have, something that's more customer facing, etc. You're evaluating for very different things, right? In one, like brand risk becomes like way more important, and there aren't any data sets. Like there's no like brand risk data set, right? There's no like I think there actually might be now. Recently, like some researchers at Stanford collaborated with like all of these like other stakeholders and released like Legalbench, which is like this very comprehensive benchmark for using LLMs for legal tasks. And it's fascinating piece of work. Would recommend everybody check that out. But then, this is like we're kind of like in the very, very early stages of like looking at, what does taking these things that we just assume humans would do right, which is not give medical advice if you're not authorized to give medical advice, and then turn those problems into data sets, right? Or don't talk about Burger King if you're at McDonald's, like take those things and turn it into data sets.
But it kind of points to, the number of these data sets we'd need, like bank bench, burger bench, like it's very, very context
Yeah.
specific.
Burger Bench. I'm looking forward to seeing that come out of like a lab, in the next 3 months. I think
McDonald's
another
AI research.
yeah, true. Yeah, I think like an interesting pattern that is very, very recently kind of like emerging. I forget, like there's an open source, I'm forgetting the name of the open source project, but there's some open source project, LMbench maybe, that essentially generates, synthetic data. Like you give it a one sentence description of the data that it wants, and it'll like keep querying, etc., and then generate a data set of what you want, etc. So I think like synthetic data can, to some degree, help alleviate the problem. But then with all of these like LMs evaluating themselves, we keep getting back to the same original problem, which is how can you trust the data set now, in the first place, right? So I think like the true way of mitigating a lot of these problems is using the LLM as this augmentation tool. So you capture what the data set is, you run it, across these different things that you want to test out a few different times, and then still go through this human curation, labeling, etc. process to build confidence. Another kind of set of work in this space is taking this actually used to be research that I did like way back in the day, but taking crowdsourcing principles, right? Which is that when what do you do when you can't trust like one human labeler, and then combining them, so that you can build confidence in like what the end product is. So taking like those techniques, etc., are like some ways to mitigate this.
So, how does the guardrails project fit into all of this? What are you trying to do with that?
Yeah, yeah. So guardrails, it actually came up a little bit organically for me, where I was, towards the end of last year, I was making some of my own applications, kind of very excited about the space. I'd worked in ML for the longest time, and including like, joining a company, because I was like, it's so hard to train machine learning models, and it shouldn't be this way. There has to be a better way, and focused on that for a while. So having the ease of, oh, I don't actually need to train a model anymore, all of it is behind an API, and I can just like use it and actually unlock the promise of machine learning, and use it for downstream tasks, right? So I was very excited about this, was building some of my own applications, and then kind of quickly discovered that even as a developer, when I was testing out what I was building, I was like, yeah, okay, this works maybe some of the times, and for a lot of the times, it's not giving me the results that I want. And this is kind of like a fundamental problem with LLMs, because they're stochastic, models at the end of the day, right? Like you're fitting them into these really complex workflows, but they are like machine learning models, and you can't expect determinism from them. So then the key insight behind guardrails was that, okay, if you can't rely on them, what can you do like surrounding them, right? To make sure that you have like independent checks, independent like tests, etc., that run, as a secondary layer on top of the LM outputs, to make sure that it actually enforces all of the correctness criteria and all of the quality criteria that you care about. So that was some of the key insight there. So how guardrails, the open source project works is, it essentially has like a catalog of what we call like validators, which essentially are, these like independent like checks that you can run on the top of an LLM, which captures like some correctness criteria, right? So, for example, making sure that there's no hallucination would be like one criteria. Making sure that there is no like medical advice would be like another criteria. Making sure that you're not mentioning competitors, etc., would be another criteria. And then within this criteria, if you have infinite budget, infinite latency, which no one has, then you are more likely to use one implementation, right? If you're much more latency constrained, then you're more likely to use this other implementation. So that's the general principle of guardrails, which is it's building like the secondary layer surrounding the LM, which allows you to enforce these criteria. So you can write custom checks and custom correctness rules, etc. You can run the whole orchestration of like running this very efficiently and like and handling validation failures very gracefully, where you can like including using the LLMs to give them context about why they were wrong, and then using that to basically like get them to self heal or like correct themselves, right? And then passing that output back through the correctness checks and seeing if you have something that works. So that's what the open source project does.
Sounds like it fits right in line with this idea that I have that behind every production NLP system is a strong regex engine.
Yeah. I think that's exactly right. A lot of this, honestly, was motivated by my background in self driving, where in self driving you essentially have perception systems which are trained on like typically purely deep learning systems trained on a huge amount of data set, right? And they're trying to figure out like where are the pedestrians around you, where the trucks around you, etc. But they don't have this like there's not they don't have this implicit understanding of like, oh, if you're at a crosswalk, it's much more likely that you're going to have a pedestrian around you than if you're not, right? Or maybe you should like so there's no like domain expertise that deep learning models can learn, right? Because there's no way to kind of like enforce that. And so typically in autonomous driving systems, any output that you get from the perception like basically goes to this like secondary layer where all of these things that you know to be true about the world are actually checked and verified and validated, etc. So autonomous driving obviously is a situation where you really cannot screw up, or or you might end up like killing someone, but it's taking that same principle and then making it very generalizable and extensible. So yeah, like pattern matching rules are one way to do it, but can you add these other can you maybe ground the output in some external system that can actually verify it and run it? Or maybe can you have like non deep learning based like very very high precision classifiers for which are more interpretable, that you can use to kind of like see if whatever criteria you care about is respected and validated and everything. So yeah, that's the general principle.
And to make it more concrete, can you give an example of type of system that you've seen it used with, and like what are the inputs, what are the rules, what can folks expect from it?
Yeah. So I think like a big use case, just because this is also where most of the industry is in terms of like what most of the industry is building, is chatbots. So then in chatbots, right, especially in some domains, you can use it to guarantee that all of these like risk criteria that you have are respected, are basically not violated, sorry. So for example, we do have some rules in there that basically check for hallucination, making sure that everything that is every sentence or every utterance that the LM generates has some grounding in what the source is, to make sure that it doesn't violate any constraints, etc. So that is like one. If you're building a chatbot, then adding those like anti-hallucination checks is like one way to account for this problem or solve for this problem. So we call it like provenance, where everything that the LM generates should have some provenance.
Is that like taking every sentence and doing a search and trying to identify the source document for the sentence?
Yeah. I think that's the key idea. I think in general, like there's a few different ways to kind of solve this problem, and then we kind of provide those as like options in the open source. So that is like one way to do this. I think another pretty common use case is around information extraction. So if you have an unstructured document, something like a PDF, and you want to from that document, extract structured data, like maybe a JSON or maybe like a table or something, right? And then write that to some database. LMs are generally pretty good at this task, but they also, might pick up like information from the wrong context. So let's say if you're talking about like an earnings report, right, and you make a reference to like the previous quarter's reports or something, so it might, when you're asking it for, I don't know, whatever the total revenue was, it might pick up the previous year's number as opposed to picking up like this year's number, right? So all of these things are basically like, you can enforce like, checks of like, okay, I know that these values should come from here, should have like this range, etc., as a way of like, ensuring like guarantees. I think another one that I really like, because we did a bunch of benchmarking on this and we found that we were, without like with using a fully off the shelf model, we were like just using our techniques. We were like, I think close to state of the art in this space. I think second or something on the leaderboard, like when we last tested this, which is generating SQL from natural language queries. So let's say you have a database and a user comes in and has a question of like, okay, how much was my spending in the last month or something. That gets converted into a SQL query, and you can run that SQL query and make sure it works. So then one type of validator we have for this text to SQL use case is um, essentially grounding any SQL that is generated in in this external system of a database, right? So we create a sandbox of your database. Any SQL that is generated, we run in the sandbox, and it's usually very cheap because the sandbox has very very little data. Or and then anytime you run it, you can figure out like where the actual errors are, right? That maybe a SQL parser won't catch, and then you can use that, give it as context, and then get the LLM to correct itself. And we find that like this gives like a pretty nice lift on top of extra existing systems, making sure that there's no risky predicates, etc. So no, even if a user wants to delete all of their data, you have like no drop
Right.
tables.
No drop all.
Gen- yeah, exactly. Yeah, so these are like some examples of the checks that the open source has. Yeah.
hmm hmm Um, is it fair to think of this as analogous to like a unit testing framework for LLMs, or do you think of those differently?
I do think of those differently. I think like unit testing is to some degree. So I think like the main difference is like what you're testing, right? So some of
hmm
these for sure might be unit tests, but then for a lot of other things, especially things that use like machine learning in the loop to like let's say a very high precision classifier, or let's say
hmm
establishing like provenance for some source, etc. There's no like 100% right answer, right? Like a unit test like like has these implicit assumptions of like guarantees, but that
hmm
doesn't exist when you're using an LLM to evaluate itself. What you're to some degree doing is creating like an ensemble model, right, where the hope is that you have these like overlapping layers where the holes in each layer are in different locations. And so the idea is that you overlap them and you end up getting something that is way more watertight than just using the LLM by itself. So I think of it like is more similar to like intelligently ensembling these models and creating something like something like basically drawing like I don't want to use the word guardrails too much, but essentially drawing like this box around where the LM is, right? Which is like, okay, here's this output, but I want to make sure that the output like with some likelihood, with some confidence, has this has these not guarantees exactly, but has been tested for these things, and these tests passed like with some confidence. So it's that difference in like determinism, which is assumed with unit testing, versus like a belief system, like a belief value or something that is like maybe more common in machine learning systems.
I guess the implication there is that or another difference, like unit testing is kind of a design time thing. It sounds like what you're describing is a runtime thing.
Yeah,
Like
yeah,
it's
that's
part
right.
of the
Yeah.
system that you deploy, and these ensembles are created real time as part of the query path.
Yeah, yeah, yeah. That's exactly right. Yeah. I think the value only exists if, especially where there's like substantial risk, and you're deploying these LLM systems or these AI systems in an industry where your risk tolerance is low. You only get the value out of this, right? If you're like constantly running it, constantly able to monitor, like, okay, which are the requests that tend to pass my tend to violate my guardrails more often than not, etc. Right? So I think like that is the general idea.
To what degree are establishing these rules a kind of templated, and the guardrails has 98% of whatever you want out of the box, b um, fairly static once you've kind of gone through your design phase, versus c, like they're constantly, teams with production systems are constantly iterating on them, and they're very, very dynamic. Where does that tend to fall?
Yeah, I think that's a great question, honestly. And my slight cop out answer is that it really depends, on the use case. So, for example, for SQL, right? Like we've done a
Hmm.
lot of our homework on SQL, and then a lot of the, like, I would say most of the building blocks that you would need for building like a very very good robust text to SQL system, like we have, in the open source. But SQL is also like a more, it's not a conversational problem, right? Like it's a one shot, like this is what I want, give it to me kind of a problem. When you're in kind of like real conversational systems that have like multiple turns, those problems tend to be like, I guess the surface area of those problems is much broader, much larger. And so there, then you get into this area of like, okay, what is the use case? What is the exact like domain that you're working with? Are you making like a Slack chatbot for, internal employee questions? Is this going to be like customer facing? What is the industry you're in, etc.? So I think like that tends to add a lot of complexity to the problem. So some of those use cases, we're like making a lot of investments, etc. Some of the other ones are, users would probably like, domain experts and users who are actually building the system tend to have like the best knowledge about like how to enforce those tools, and they're also like very very specific. So then we provide a general framework for, creating your own custom validators and then running them from within the orchestration system.
Do you find that guardrails is kind of sufficient to solve these problems for folks, or is it, one piece of the puzzle, and there are other pieces that are commonly employed to help build the entire system?
Yeah, I think it depends on like the problem that you're targeting. For basically having like more confidence, and more kind of like just assurance essentially in the outputs of the LLMs, like guardrails is the, is the way to kind of make sure that you're getting that reliability, you're getting that confidence, etc. But in general, if you care about like AI safety as a whole, right, then there's a lot of like other concerns that you would have as a stakeholder, depending on where, like, once again, which industry you're in, like what your primary concerns are, etc. So privacy and data leakage, for example, is a top concern that people have, and they want to make sure that if they're using the system constantly, then they're not, sharing data with commercial LLM, providers that then gets used to train these models, right? So a lot of people want to use LLMs, but make sure that none of their data is actually leaking like their, like their cloud or something. So in that case, like privately hosted fine-tuned LLMs are kind of like another safety measure that you can use, right? I think one more criteria here is like very very extensive offline evaluation and testing. So guardrails, like you mentioned and like I talked about, they're kind of like this runtime thing where as you're running this, you can like you figure out for each request like where your risks are and what is getting violated, etc. But then before shipping any workflow into production, like across that entire workflow, figuring out, what the like essentially how does it do on like benchmarks and some evaluation, etc. So more, techniques that are common in machine learning, right? Creating a data set, running a bunch of tests, like looking into it in a very fine grained manner, like analyzing where the errors are, making sure that those errors are acceptable to you, as a builder before you put it into production. Like I think that is another kind of like essential way. And then outside of that, essentially like documentation of like models, metrics, like the use case that you tested for, etc. So those are some of the other kind of like techniques you can use if you're generally talking about AI safety.
Okay, awesome, awesome. Well, we'll be including a link to the Guardrails open source project and Guardrails the company in the show notes. Are there any other resources or things that you'd like to point our listeners to?
Yeah, so I am basically, there's a Discord associated with the open source project. So check out the Discord, especially if you decide to give it a spin. We're pretty active on Discord and on the GitHub with responding to any issue that comes up. And then yeah, follow me on Twitter. I tweet about like guardrails and the open source and generally the space pretty often. So yeah, I'd recommend that.
Awesome. Awesome. Well, Shreya, thanks so much for joining us and sharing a bit about what you've been working on.
Yeah, absolutely. This is really enjoyed being here, and it's absolutely great, like actually chatting with you after like years of listening to you talk on the podcast. Yeah.
Awesome. Thanks so much.